Now let's see how to represent this number 4.875 using explicit number representation, and we shall see why implicit will be useful here. So 4 is 100 and 875 is 111. So 0.5 plus 0.25 plus 0.125, it is going to be 875, 0.875. Right? Now if I try to represent this in explicit normalization, I am supposed to write it this way. So I have to move this radix point 3 points to the left, which means 0.100111 into 2 power 3. Right? So assume that we have the representation this way. So we have already fixed the representation, and our representation is going to be 1 bit is for sign, and then there is some exponent, and then there is mantissa. So assume that the mantissa we have is for 5 bits. Then the problem with this representation is, if I have to save these 6 bits in this 5-bit field, I'll have to discard this. Are you getting this? Here I have 6 bits and here I have only 5 bits to represent. Then I will have to discard it, which means 10011 will be represented, right? And what about this exponent? Let us say in the exponent I am using 4 bits. So if I am using 4 bits, it is nothing but excess 8, isn't it? So how do I get it? In 4 bits, if I use 2's complement, the maximum negative number possible is minus 2 power 3, which means minus 8. Therefore I am going to use a bias of plus 8 to make everything positive. So if there is 3 here, I am going to add 8 and I am going to save 11 there, right? So 8 plus 3 is 11. Now what is it? 1011 will be saved. That is the exponent, and now sign bit is going to be 0. Got it? So if you observe this representation, again if I have to convert back to the actual number, the formula that we are using till now is, in explicit representation, the formula is minus 1 power s into 0.m into 2 power exponent minus bias. Exponent minus bias is 8, right? So if you write this, you are going to get it as minus 1 power 0 into 0.m is 10011, right, into 2 power e minus 8. So e minus 8 is, here e is given as 11, 11 minus 8 is 3. So if you see this, I am going to get 0.10011 into 2 power 3, right? So which is going to be 100.11. Now if you convert this value back, you are going to get it as 4 and 0.5 and 0.25. So which means 4.75 is what you are going to get. Now this is the number you try to represent, but because of the less number of bits in the mantissa, you are able to get, you are actually storing this number. So there is some error, isn't it? So in order to save this, there are 2 ways. So if you have to save the exact number, there are 2 ways. One way is either you increase the number of bits in the mantissa field, that way you can do it. Other way is maybe you can use some other better method using which you will be able to represent the same number using less number of bits, right? So now that is called as implicit normalization. So implicit normalization says that anyway you know that, anyway you know that there is there is going to be 1 to the right of it. Now instead of moving this radix point till this to the left of the most significant one and then saving this entire number, just move it to the right of it and then save this remaining number. That way you can save better. So what normalization, implicit normalization says is, the same number 10011, the same number could have been represented this way. So go till the most significant bit, but then don't go to the left of it, just stay to the right of it, which means go till this point 00111. You have moved the radix point 2 points to the left, which means you have decreased it, so you increase it, so 2 power 2. Okay, now don't save this one. It is implicit, which means it is already implied, you know that, so don't save it. Now save the remaining part only save this part. Okay, so now the implicit representation says that if you are going to use this representation, one is sign and let us say exponent is using 4 bits, and then there is mantissa is using 5 bits. Then in the exponent you are going to do the same. Sign is going to be 0 because it is a positive number, and exponent is going to be excess only. So how much excess? Excess is 2 power n minus 1, so which means here the excess is 8. So take the actual exponent here, which is 2, and you add 8, it is going to be 10, which means you are going to write 1010 there. And what about the mantissa? In place of mantissa, you need not worry about the 6 bits. Now you have to save only 5 bits, so which is going to be 00111. So by using implicit representation, you will be able to save the same information, using 1 bit less. Why? It is already implied. Anyway, you are going to have 1 to the right of this, so now you know that it is to the left of it, so it is already there. Now how to convert it? The formula that is used to convert, if you are going to represent the number this way, is important. Now what is the formula that you are going to use? Minus 1 power s sine into now 1 point m. The reason is this is what my new m is, isn't it? That is why it is 1 point m into 2 power e minus, here since you have added 8, now you are going to subtract 8. So in this case this 8 is applicable, so you have to be careful only at this part. The entire formula is same. Depending on what the bias is, you are going to change this number. So let me write it as e minus bias, right? Therefore this is the formula we are going to use in case of implicit normalization. And what about the formula that we are going to use in explicit normalization? This one, right? So let me write it as minus bias. Right. So what is the advantage of implicit normalization compared to explicit normalization? So we are going to represent the same number using 1 bit less in the mantissa, because 1 is not represented in the mantissa field, 1 is represented outside and it is present in the formula. So whenever you try to convert it back, that 1 is going to come back. Got it? So if you have to convert this number, it is going to be minus 1 power 0 into 1 point m is 00111 into 2 power e minus bias. So e minus bias is going to be so this is 10 minus bias is 8, which means 2. So you are going to get 1.00111 into 2 power 2, so which is nothing but 1111. So you got it, right? You got the actual number. So what is the advantage? 1 bit. So now what are the methods we have seen? There are various ways you might have to represent a number. There will be various representations. So just to use only one representation for every number, we are going for normalization. Now again in normalization we are going to have the biasing. So what is biasing is, in order to compare two fractions, when the exponent is represented in a negative number, it will be difficult. If the range is from some minus 15 to, let's say, minus 16 to plus 15, and if you have to compare two numbers in that range, given the numbers are in binary, it is difficult. That is why we are trying to bias, and we are trying to get every exponent to the positive number. Now the comparison will be easy. Now again, coming to normalization, we have two types of normalizations. One is explicit and other is implicit. Now what they are trying to use, what is the bias they have used, and what is the normalization they have used, everything they will mention in the question. From that you can solve the questions. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs. per year, and in India the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.